everybody, I hope you're doing well and welcome to the platform of Codechef. Today we're going to be solving the problem Chef 39 Dream. The difficulty level for this problem is easy and the prerequisites required are your greedy algorithms. So this is your educator Ansh and I hope you like my video. Let's proceed to the problem statement. Okay, now let us try and understand the problem statement. The chef is sleeping now, so he tries to cook new kinds of meals in his dream. These meals are arranged in row and columns, numbered from 1 to n consecutively. For each meal I, there is given an integer f of I, which denotes the time needed to cook it. Initially, all meals are uncooked. Each assistant of the chef can help him with the cooking. The abilities of all assistants are the same. That can be at most one assistant cooking at each moment. He must choose some continuous subsequence of meals with length k. Any subsequence can be chosen, and if there are uncooked meals in it, he will cook all uncooked meals which has the minimum cooking time among all uncooked meals in the chosen subsequence. Nothing can be done to the other meals, but nothing is done to that other meals in that particular step. The dream was so interesting that he tried to solve such a problem. What is the minimum number of assistants which can cook all the meals, assuming that each of them will cook at most once? But since bell rings and Chef Render come to visit him, he will wake up after 2 seconds. The program should calculate the answer before chefs come to visit himself, right? So now let me just summarize what the problem is saying. The problem says the following things, that initially you're given an array A of length n. Now what you're given is basically you're given an array A of length n, and now you'll be given a subsequence or you're given a k. So the k denotes that you can choose a contiguous subsequence of length 3 in this case, right? So what this contiguous subsequence means? So say in an array of 1, 2, 3, 4, 5, my k is equals to 3 or any contiguous sequence of length 3 means that you can pick up any subsequence which is continuous and which is of length 3. For example, these three elements or these three elements or these three elements. My 1, 2, 3 is one of the valid subsequences, my 2, 3, 4 is one of the valid subsequences, and my 3, 4, 5 is also one of the valid subsequences. So this is what the question is meant by continuous subsequence. Now, what the problem basically says is that let us understand the exact meaning of the problem using this example test case. So I'll write this problem here. So 40, 30, 40, 30, 40. Now the problem says is what you can do is you can select any contiguous subsequence of length 3. And then what you have to do is whatever is the minimum element of that particular sequence, you can remove all the occurrences of that particular minimum element. So example, what if or basically I can cook that particular dish. So let's say I choose my subsequence length to be from 2 till my index 4, right? So let us number this 1, 2, 3, 4, and 5. So this is a subsequence of length 2, so length 3, right? So my k is equals to 3. This is my k equals to 3. I consider these three elements and check the minimum of all these elements is 30, right? So after that, after by applying this particular operation, we can cook meals this 30 and we can even cook this meal 30, right? Because 30 is the minimum element and in one move, you can cook all the meals having the minimum value. So here, since this minimum element was 30, you can cook both of these meals in a given operation. So currently, we did one operation and we cooked both of the meals which are 30, right? In the second operation, what I can do is I can choose this length subsequence. Note that although the meal is cooked, but the position remains still occupied, right? So while considering the subsequence, you have to consider this position as well. So now note that my 40 and 40 are current, but this 30 has already been cooked. So currently the minimum meal or the cooking meal has 40 value, right? So in given operation, I can cook all the meals having the minimum value. So since my 40 is the minimum value and even here it is 40, I can cook both of these meals and my 4 meals are cooked in 1 plus 1 move. So my last move is 40. So again, only one of it is remaining. So I can choose this subsequence of length 3. And what I can do is, the minimum element in it is 40 and the 40 element will be cooked. Hence 1 plus 1 plus 1. And you can get the answer in 3 moves, right? Hence the answer for this test case is 3. And this is what the problem is saying. At any given point, you can select a k length subsequence and then whatever your answer is getting, you can get your answer in such a way. So which are in how many times you have to select a subsequence of length k such that your all meals will be cooked. So this is what the problem is asking. Now, how to approach such kind of problems? So this problem is mainly a greedy solution. So what you can do is, firstly, you can try to pull or basically try to select the subsequence having the minimum element and having as much range as possible. So let me just show you how exactly can you do the problem. So first what you'll do is you'll create a hash map. So say I have created a hash map which is currently empty. Now for each and every value I'll append its position. So in the hash map my 40 as a key will have its position as 1, my 30 as a key will have position as 2, my 40 will be appended with a position of 3. So basically what I'm saying is for 40 key. Okay, so what we'll do is initially we'll create a hash map which is empty. Now we'll create a hash map which has a key corresponding to an array or a vector, right? So the key is the key and the value is correspondingly a vector. So for each and every value in the array, we'll append the position in the vector. So currently my 40 has position 1, 3 and 5 and my 30 has the position 2 and 4. So what I'll do is for 30 key, positions 2 and 4 will be appended in the hash map. And for position 40, my positions such as 1, 3 and 5 will be appended in the hash map, right? Now, what we'll try to do is obviously the minimum element will get popped first. So we'll choose 30 and we'll try to remove all the occurrences of 30 greedily. So what I'll do is I'll go to 30 because 30 is current minimum element. I'll go to my first index which is 2, right? For say if I want to generate a subsequence of length k starting from index 2, what is the maximum length subsequence that I can generate? 2 plus k minus 1, right? So here I try to generate my 2 plus k value is 3. So 2 plus 3 minus 1 which is 4, right? So you were successfully able to generate a subsequence from 2 to 4. So here since my ending value becomes 4. So it is given or basically I calculated if I want to start a subsequence at 2, maximum I can extend it till 4 and whichever minimum values will be covered between 2 to 4 will get erased, right? So I go to my 2, I generate my ending value which is nothing but 4. I go to my 4, my ending value or my 4 is less than equal to 4, right? So it is possible to generate, so even this value will be covered and we will remove both of these values denoting that this particular value can be done in one operation. So this becomes the solution for the first key. Now this key or basically we completed all the keys in 30. So we'll move on to the next minimum element which is 40. Then we'll point at the first key. Now I have 1. So what is the maximum value that 1 can handle? 1 plus k minus 1, right? Which is 1 plus 3 minus 1 which is equal to 3. So if I am starting at a subsequence of length 1, the maximum k length subsequence that can be formed will end at 3. So here I can cover 1 and 3 from that particular subsequence. So these will get removed and it will be done in one operation. And for the final 5, we have to perform one more operation to remove this subsequence. Hence, the answer will be easily calculated with 1 plus 1 plus 1 which is equal to 3. And this is the exact approach that we're going to use to solve this particular problem. Now you'll get a complete understanding of this particular approach when you see the code for this particular problem. So let us proceed to the coding section. Okay, now let us try and discuss the code for the following problem. So here I included my n and k and my array according to the input format. And I initialize my answer as 0. And as I discussed in the approach section, I initialize my hash map, which is nothing but a dictionary of Python, or in C++, it's just a normal map, right? With the value as a list. List is nothing but an array. So as I discussed in the approach section, for every key, by default, we have an empty array in my hash map, right? Then what I do is I traverse in the n length and I append the value of key with its particular position, right? So as we discussed, 40 will have its key such as 125, 135, and 30 will have its key as 2 and 4. So I append those particular positions. Now I extract the value of keys from the hash map. So we extracted the value of 30 and 40 using the example if I wanted to explain. Here, my keys will be an array which contain the sorted list of all the keys present in the hash map, right? So we obtain the value of 30 and 40 as an array in my keys. Now, as we discussed, firstly, all the values of 30 will be removed. So we traverse in the keys, and that's why I sorted the array because I want to remove the minimum values first. Then I initialize my NN as the length of hash map of I, right? Every key of hash map has a value that is an array, right? So obviously it also has a length parameter. So I initialize my NN as the length of that particular array. Then I initialize my previous index such that it is nothing but my first element of that particular array. So we are traversing in the keys, and currently I'm pointing out at the first element in the hash map value of that particular key, right? Then what I do is I generate the end value. So this is what I discussed in the approach section. Once, say I'm starting at any index which is such a 1. So I want to know what is the maximum length of subsequence that can be used for that particular starting point. So it will be nothing but previous plus k minus 1, right? I showed this working in the approach section. And then we increment the answer by 1 because we are using this particular segment as our operation, right? So we are choosing this index from L to R. The starting point is previous, the ending point is previous plus k minus 1. So we increment this operation denoting that we're using this particular operation. Then we initialize my j equals to 1, which is going to traverse in the array which is currently contained in the hash map, right? So after that we traverse in the array. If my particular index in the hash map, or basically in that particular key of the hash map, is less than the ending value, then we pass denoting that this particular index is going to be considered in this particular answer. So whatever operation is going to cover the entire value. Otherwise, what we do is we initialize a previous value to hash map of I comma j, or whichever index that I'm currently standing on. I again increment my answer, and I again update my ending. So we are trying to do the following thing every time we are picking the smallest value. Then what we do is for that particular value, we find the first occurrence of that particular value. Then what we do is we try to generate the maximum possible subsequence of length k, and we try to cover as many minimum elements as possible. Once we cover all those minimum elements, we switch on to the next element and again do the same thing for that particular element as well. So this is the entire operation that has been going through. So now let us run our code on the sample test cases to check whether our code is working perfectly or not. So as you can see, we got the exact output according to the output format. Now let us submit our code on the actual test cases to check whether our code is working perfectly or not. Okay, so as you can see, we got the correct answer verdict for the following problem. And yes, this becomes the right approach to solve this particular problem. So let us discuss what are the mistakes people can make in solving this particular problem. Here, the key learning was that if you know the greedy method of solving this particular problem, you can easily solve this problem using a hash map. If otherwise, you have to do some kind of complex implementation, which might result in a wrong answer verdict. Try to keep your problem as simple as possible, and then you can easily get the correct answer verdict in just a simple few lines of code. Right? There's the learning you get from watching my video. I hope you like this video. Please like, share, and subscribe to our channel. Thank you.